Hey there, welcome to a video discussing section 5.7, the problem sets. I understand that some of you guys had a hard time doing these problems, and I definitely take blame for the first four because I don't think I gave you guys clear enough instructions as to what to do, so definitely my fault there. So I have to find all zeros. What I want you to do is find the real zeros and the imaginary zeros. Now, I did go over an example of this from the 5.7 lecture notes, but I think the instructions here is what's a little confusing. So, my expectation is for you to use synthetic division with a known zero. Here's the dilemma, and I can see why you guys are confused. What is a known zero? You don't know what it is, right? So the second step actually should be the first step. So we'll call this 1b. 1a is a graph f of x in the calculator to find a rational zero. Remember, rational zeros are zeros that are rational numbers. Rational numbers are numbers that can be a ratio of two integers. And remember, we did the P over Q thing, so it might not be such a bad idea to actually do that, and we'll actually do number 2 together. So I know the constant's -8, so these are all the possibilities, or all the factors of 8, and all the factors of my leading coefficient are just, it's 1. So all the possible rational zeros are this. Now, I don't want you doing trial and error. What I want you to do is graph f of x in your calculator and see which of these 8 possibilities is happening. Once you know that, then you can use synthetic division with that number. That's what you want to do. And that's how you do these problems here. So I'm going to go to Desmos, because I don't have a TI-84 emulator in my calculator. Sorry, the TI-84 emulator on my computer. So y equals x raised to the 4th power. Let's see. Why am I struggling here? Y equals x. Oh, there we go. To the 4th power plus x cubed. Plus 2x squared plus 4x minus 8. Okay, so we do see a known zero, or recognizable one, -2 and 1. So you can do synthetic division for either one of these two. Now, it's interesting because this is degree 4, and I only see 2x intercepts, so it tells me the other two are probably going to be imaginary. Because we do expect the number of zeros to equal the degree, but not all the zeros could be real. Some could be imaginary. So anyway, I'm going to do synthetic division. So I'm going to put my coefficients in here. I already forgot what they were. 1, 1, 2, 4, -8. And let's say we start at -2. Drop the 1 down, multiply, add, multiply, add, multiply, add. Good. So now we got a new polynomial. X cubed minus x squared plus 4x minus 4. Now the calculator told us that 1 was already a 0. Now you could graph this one again if you like, or you can use factor by grouping. But if you want to use synthetic division one more time, because you know that 1 is a 0 from our original graph, and if you were to graph this, x equals 1 would be a 0, because it was a 0 from where it originally came from. So you just do it again. So now you get yourself x squared plus 4. Set that equal to 0, and you should get plus or minus 2i. Remember, you're square rooting a negative number. So what you need to do again is take the function that you see there, graph in your calculator. Yes, you can use Desmos, but on the test you're going to have to use a calculator, and other assessments later in math courses you can't use an internet resource. So graph in your calculator, but it probably helps to know the possible rational zeros by doing the P over Q thing, so you know what to look for. because Desmos kind of just tells you right away, but in the TI-84 calc it's not very obvious. But at least you know what to look for. We set -2 as a 0, we did synthetic division. Then I did it again, and remember I did x equals 1 because I also saw that as an x-intercept from the original graph. Once I had it broken down to a quadratic, you can use quad form if you like, or just, if it's very simple, like x squared plus 4, just isolate the x squared both sides. So you're going to do something similar for numbers 1, 3, and 4, just so you know. Okay, next up, we've got 5 through 8, which is writing a function with these as a given 0. So you're kind of working backwards. So I'll do number 8. And actually make a new page here. Let me copy and paste that. Actually, let's do this. Okay, so let's focus on number 8. So I'm asking you to write a polynomial function of least degree. So that means I don't want you doing like a 5th or 6th degree. Just do the bare minimum. But your coefficients have to be rational. So it means no imaginary or square roots in your coefficients. We'll keep the leading coefficient of 1. That's actually to make this easier for you, and use the given zeros. And also I want this in standard form too. I forgot to mention that in these instructions. So it means I want the exponent to go in descending order. So I want the highest exponent first and just work your way down to the constant. So if you're told that -4 is a 0, you have to have x plus 4 as a factor. It's just x minus the number you see there. Likewise with 1, we're going to do x minus 1. And then you're going to do x minus 2 minus root 6. And you have to do the conjugates, because if we don't, then you're not going to get the rational coefficients. So you have to do the opposite of 2 minus root 6, which is 2 plus root 6. For 2 minus I, you're also going to do 2 plus I. Or for plain old I, you're also going to do negative I. This way you guarantee the rational coefficients, because rational numbers are real numbers too. So you can't have imaginary coefficients. Now, at this point, you're just going to FOIL. The problem is that this is a real pain to do, because x plus 4, x minus 1 is fine, but the other part, x minus 2 minus root 6, x minus 2 plus root 6, that's kind of a nightmare. So I'm going to show you guys a better way for doing this. Well, this part's easy. I'm just going to get that out of the way. X squared plus 4x minus 4, x squared plus 3x minus 4. Okay, told you it's easy. We got that out of the way. For this bit, I'm going to show you a little trick you can do. We distribute the minus, so you get this. Distribute the minus, you get this. And you're going to regroup it. Like that. So now this becomes a difference of 2 squares. Hopefully you remember what that meant. The difference of 2 squares is when you have a squared minus b squared equals a minus b, a plus b. Well, if you think about it, that's like my a. That's like my b. A plus b, a minus b. So really, I could just say this. X minus 2 times x minus 2. Boom, there you go. Negative root 6 times x minus 2. Positive root 6 times x minus 2. Those are going to cancel. That always happens. The outside inner terms will cancel using the difference of 2 squares. And in root 6, it's a positive 6, but there's a negative because you have a positive and a negative. So then you just get x squared minus 4x plus 4 minus 6. X squared minus 4x minus 2. Oh, okay. And remember what we had earlier as well. X squared plus 3x minus 4. Then you just kind of just FOIL. Well, not really FOIL, because it's many terms, but x4 minus 4x cubed minus 2x squared. We'll just go through the motions. Plus 3x cubed minus 12x squared minus 6x. Notice I'm now working on the 3x. Then finally I got to work the -4, -4x squared plus 16x plus 8. So final answer, our function is going to be x4 minus x cubed negative 18x squared plus 10x plus 8. And just to be sure that I did this correctly, I'm going to go to Desmos. That's always how you can check your work. X4, just going to, instead of having to read this, alter this really quickly, minus 18 plus 10x plus 8. Okay, cool. So I do see negative 4. Awesome. I do see 1. we were told those are zeros. Now, you have 2 minus root 6. If you actually were to work out 2 minus root 6, it does come out to negative 0.449. And then 2 plus root 6, if you were to work that, it does come out as 4.449. So we know we've done this correctly. And the end behavior makes sense. The arrows are pointing up on both sides. The y-intercept makes sense. It's at 8. We have 4 zeros total, which we should because it's degree 4. So now everything is working out just fine here. So that's how you would go about these problems. Just for number 9, what you're going to want to do is set this expression equal to 1.5 million. So you're actually going to have to do 1, 5, 0, 0, 0, 0, 0, 0, 0, right? Because it's 1,500,000. And you'll distribute the 0.0001 into this, move the 1.5 million from left to right, and just graph in your calculator. And then just find the x-intercepts. So that's what you could do for number 9. And don't worry about the 12 years. That's just that just tells you like how long you could use this function, but don't worry about that. It doesn't really matter in the problem. And then you guys will do 5/8 today. And I think the video is pretty clear about that. You're going to find your x-intercepts, you're going to find your y-intercept, you're going to figure out the end behavior. If you guys are stuck, rewatch the videos. I think that's probably the best thing. Or if you didn't watch it very carefully, do watch it carefully because they do kind of explain how to do these problems. But I will admit that I wasn't quite clear with the instructions here. I should have told you guys to find a 0 first. By the graphing calculator. That's my fault. So hopefully that helps. And I obviously won't see you today or tomorrow, but I'll be back on campus on Monday. All right, and of course, I know it's just Thursday, but have a great weekend. Goodbye.